Okay, now let's just look at the functions that we get. We have y equals x squared. We vertically stretch by a factor of -2, as we've done over here, which means that we multiply our y values by -2. Our y value for the point -1, 1 is 1. So that when we multiply by -2, we're going to multiply the y value 1 by -2, and that gives us the point -1, -2. And similarly with the rest of the points, we multiply the y value of 0 by 0, and we still get 0. We multiply the y value 1 by -2, we get -2. The point 1, 1 goes to the point 1, -2. Okay, so if we do that, if we multiply our y values by -2, then we're going to have to multiply the x squared value by -2. And that's going to take the graph, it's going to take it from the basic parabolic graph, it's going to turn it upside down and make it narrower, as we've seen over here. Then our horizontal shift of +5 units means that we replace x with x minus 5. Now, it's not that easy to understand why we have a minus here when we have a plus here. I simply say that if you want the same y value, x is going to have to be 5 units greater. So that, for example, if we want to get y equals 0, then x minus 5 would have to equal 0, which means that x would have to equal 5. So our vertex is going to have to be at x equals 5. That's been discussed at some length in other videos and in class. But whether you understand it or not, that's the rule. So the function becomes, instead of y equals -2x squared, when we replace x by x minus 5, we have -2 times the quantity x minus 5 squared. Vertical shift -3, well, that's going to decrease our y values by 3 units. And to do that, we're going to have to subtract 3 from our previous y value, and we get this function. And the graph, of course, does this, okay? Now, for any function, y equals f of x, vertical stretch by factor -2 is going to multiply all our y values by -2. And if we start with the function y equals f of x, applying a vertical stretch by factor -2 is going to give us the function y equals -2 f of x. All our y values will then be for any x value. For any x value, we get an f of x value. If we multiply that f of x value by -2, that becomes a y value that's -2 times what it was before. So we've vertically stretched the graph by factor -2. The horizontal shift to +5, for the same reason over here, we're going to replace x by x minus 5. We get -2 f of x minus 5. Vertical shift -3, we're going to have to subtract 3 from our y values in order to shift all our points 3 units downward. That's going to give us y equals -2 f of x minus 5, excuse me, minus 3. So that's our general result. Now, if the function is, let's say, y equals, let's move this over a little bit. And we just went out of focus. I don't know why that happens. Well, I kind of know why that happens. Okay, I don't know exactly how the camera's designed, just what microprocessor doing what in there, but okay, anyhow, we got y equals, let's say, now the reciprocal function. Okay, and let's say we want to do the same vertical shifts and vertical stretches. Well, let's go ahead and give the specifics of the reciprocal function. The specifics are that the basic points are -1, -1, and 1, 1. Okay, vertical asymptote going to be the y-axis, as we've seen very recently. Horizontal asymptote that's going to be the x-axis. Now, if we vertically stretch by factor -2, same vertical stretch and so forth we've been using, same vertical stretch, horizontal shift, and vertical shift. Well, vertical stretch by factor -2, it's going to take the -1, the y value of this basic point, and multiply it by -2, we're going to get -1, 2. And here we're going to get 1, -2. We do vertical asymptote with the y-axis. What's going to happen to that? Well, the vertical stretch will stretch the y-axis, but the y-axis isn't going to go anywhere. It's still going to be right where it was, okay? So the vertical asymptote is still going to be with the y-axis if we vertically stretch it by a factor of -2. The horizontal asymptote, the x-axis. Every point on the x-axis has y-coordinate 0. So vertical stretch of -2 is not going to affect the x-axis at all. So the horizontal asymptote will still be with the x-axis. So vertical stretch factor -2, we're going to get y equals -2 over x, and we're going to get the points 1, 2, and 1, -2, -1, 2, and 1, -2. Vertical asymptote is still the y-axis, because moving a point on the y-axis further from the x-axis doesn't take it off the y-axis, it just moves it to a different point of the y-axis. So every point of the y-axis will still go to a point of the y-axis. And we could say more about that, but the y-axis is going to remain just where it is. The vertical asymptote is going to remain just where it is. The horizontal shift, well, we haven't done the horizontal shift. The horizontal asymptote is still the x-axis. So at this point, our graph is going to look like so. Now let me use a different color here to mark our unit points. For the graph of y equals 1 over x. Okay, so here's our graph of y equals 1 over x. In green. And to graph the refined function, or the vertically stretched function. Oops. 1, 1 is going to map down to 1, -2, and 1, -1 will map up to -1, +2. So now our graph is going to look something like this. Okay, so this would be the graph of y equals -2 over x of white, having this part and this part. Now, if we want to then do a horizontal shift of +5, what's that going to do to the graph? And then what's a vertical shift of -3 going to do to the graph? Well, horizontal shift of +5 is going to shift this graph over 5 units. And it's going to shift the vertical axis over 5 units. It's going to shift these points over 5 units, the basic points, and the vertical asymptote, okay? And then if we do a vertical shift, -3, what's that going to do? It's going to take the resulting graph and move it down 3 units, which is going to take the horizontal asymptote with the x-axis and move it down to the line y equals -3. So you should pause and sketch what the result of the horizontal and vertical shift will be before you watch me do it. Okay, sketching a picture. The points have redrawn the graph of the y equals -2 over x function. The points -1, 2, and 1, -2 are going to shift 5 units to the right. That's going to put them at 4, 2, and 6, -2, as you should be able to easily verify. It's also going to take the vertical asymptote and shift it 5 units to the right. So we've got the points, we've got our vertical asymptote, and it doesn't affect the horizontal asymptote. The result is then a graph that looks something like this. Okay, so we have our vertical asymptote, still horizontal asymptote with the x-axis. And now we're going to do the vertical shift by, we're going to shift it vertically -3 units. You should sketch what you think is going to happen when we do that. Okay, vertical shift of -3 is going to shift 6, -2 down to 6, -5. And it'll shift 4, 2 down to 4, -1. So we're going to be at 4, -1 here. We'll have these points. Our horizontal asymptote was the x-axis, but now we're going to lower that by 3 units, and the horizontal asymptote is going to become the line x equals -3. So we have the vertical asymptote, we have the horizontal asymptote. We can sketch our graph. Something very much like this. And that's going to be our new graph. Okay, and now this graph after the vertical stretch was -2 over x. We did a horizontal shift 5, which replaces x by x minus 5. So this function is -2 over x minus 5. And then we did a vertical shift -3, so that the function is y equals -2 over x minus 5 minus 3. Now recall why our vertical stretch made the function -2f of x. -2f of x is -2 times 1 over x is -2 over x. -2 over x is therefore equal to -2f of x. And this function up here agrees with the form y equals -2f of x. The horizontal shift, we replace x by x minus 5, and we get a -2 times f of x minus 5. So we take the -2f of x, we replace x by x minus 5, we get this, which is -2 over x minus 5. So we again agree with the form y equals -2f of x minus 5. And then at the bottom, we subtract 3 from this form. We get -2f of x minus 5 minus 3, which is the form we should have. And that is -2 over x minus 5 minus 3.